So here are some odds and ends about acids and bases. First thing I want to talk about is naming. And if we have a base, there's only two words in the name. We first name the metal, that's the first word. The second word is usually always hydroxide. So for example, this would be name the metal, calcium hydroxide. Or in this case, lithium hydroxide. So bases are pretty simple. For acids, most of those that we're going to look at contain polyatomic ions. And if the polyatomic ion ends in 8, then we change the ending to ic and put acid on the end. If the polyatomic ion ends in ite, then we change the ending to us. So for example, if I have HNO3, NO3 is called nitrate, so I would change the 8 to ic, so nitric acid. Or if I had HNO2, NO2 is nitrite, so I would change the ite to us and call it nitrous acid. Okay, so if I want to go backwards on naming, let's say I have a base and they give me the name, strontium hydroxide, and I have to write the formula. I would find strontium and look up its charge, then polyatomic ion hydroxide, and its charge is -1. Those two don't add up to 0, so I have to crisscross, so the 1 goes here, I can leave off the 1. The 2 would go here, so I would need a total of 2 hydroxides. If they gave me potassium hydroxide, I would write down potassium and its charge, and hydroxide and its charge, and in this case, those two add up to 0, so I would just write it as KOH. If it's an acid, let's say they gave me sulfuric acid, if it's an ic on the end, I know that means it came from the polyatomic ion sulfate. So I would write down sulfate with its charge. And in order to be an acid, that means it has to go with H. So those two don't add up to 0, so the 2 would come down here. The 1 goes over here, and I can leave it off. So it would become H2SO4. If they gave me chlorous acid, that tells me that this came from the polyatomic ion chlorite. So I would write down chlorite and its charge. And I know that if it's an acid, that means it has to have H with it. So H is a +1, chlorite is a -1. Those two add up to 0. So that means it's just going to be HClO2. For oxides, I have a metal oxide, that is a metal with oxygen. And when we react a metal oxide with water, then we make a base. So for example, if I have sodium oxide, so here's a metal with oxygen, I react it with water, I make a base, and bases have OH on the end. And in order to balance this equation, I would just need to put a 2 here. So I have 2 NAs, 2 NAs, 2 O's, 1, 2 O's, and 2 H's. Non-metal oxides would be a nonmetal with oxygen, and a nonmetal oxide with water yields an acid. So if I have sulfur trioxide, that would be a nonmetal oxide, react it with water, and I'm going to make an acid. So in this case, it's H2SO4, because I have 2 H's, I have an S, and I have a total of 4 O's. Last topic are carbonates, and a carbonate is a substance that contains the polyatomic ion carbonate. That's why they're called carbonates. So you're going to look for CO3 in your formula. And if we have a carbonate with an acid, it's much like a neutralization in that I form water, carbon dioxide, and a salt. So if I have sodium carbonate, and I recognize this CO3, react it with HCl, I know I form water, so that's H2O, and carbon dioxide, which is CO2. So now in order to figure out the salt, I'm going to cross out the C's and O's and the H's, and the pieces that are left make my salt. So I'm going to write Na, it's a plus, Cl is a minus, and those already add up to 0, so that means I don't have to do any crisscrossing. All that's left is to balance my equation. I have 2 NAs, so I'm going to have 2 NAs. I have two Cl's now, so I'm going to need to have two Cl's. I have two H's, I have a C, I have a C, I have a total of 3 O's on the left, and 2 plus 1 is 3 O's on the right.